14.5 billion miles from where you're sitting right now, a spacecraft the size of a small car is falling through absolute darkness. No engine running, no pilot, no plan B if something breaks. Just a radio dish, a handful of dying instruments, and a signal so faint that by the time it reaches Earth, it's a billionth of a watt. Weaker than a snowflake landing on a scale. That spacecraft is Voyager 1. It has been flying for nearly 49 years. And in November of 2026, it is about to do something no human-built object has ever done before. But to understand why that moment matters, why NASA engineers have spent years quietly bracing for it, you have to go back to a launch pad in Florida, back to a chance alignment of planets that happens once every 175 years. And back to the night, not long ago, when Voyager 1 stopped making sense and the people who built it thought they might be listening to its last words. This is the true story of the machine that talked back from the edge of the solar system. In the late 1960s, a NASA engineer named Gary Flandreau noticed something almost nobody else had caught. Once every century, and three-quarters, Jupiter, Saturn, Uranus, and Neptune line up in such a way that a spacecraft could use each planet's gravity to slingshot toward the next one, a grand tour of the outer solar system, using almost no fuel of its own. That window was open in the late 1970s. NASA built two identical probes to use it, Voyager 1 and Voyager 2. Each one carried less onboard computing power than the key fob that unlocks your car. Their memory is measured in kilobytes, not gigabytes, not megabytes, kilobytes. Voyager 1's entire onboard computer holds about 70 kilobytes of memory. A single photo on your phone is bigger than that. And yet, this is the machine that was about to rewrite what we knew about the outer planets, and then keep going for half a century afterward. Voyager 1 launched on September 5th, 1977 from Cape Canaveral, riding a Titan Centaur rocket into the sky. It flew past Jupiter in 1979, capturing the first close images of the Great Red Spot and discovering active volcanoes on the moon Io, the first ones ever found beyond Earth. It reached Saturn in 1980, threading past the rings and the moon. Titan, in a maneuver so precise it also ended Voyager 1's planetary tour for good. The flyby bent its path up and out of the plane of the solar system, sending it toward interstellar space instead of onto Uranus and Neptune. That job was left to its twin. From that point on, Voyager 1 was headed only one way, out. In 1990, at the request of the astronomer Carl Sagan, mission controllers turned Voyager 1's camera around one last time and pointed it back at Earth from nearly 4 billion miles away. The image it sent back showed our entire planet as a single pixel, suspended in a beam of scattered sunlight, the pale blue dot. After that, the cameras were switched off for good to save power. Voyager 1 has not photographed anything since. For the next 2 decades, it kept moving outward, about 1 million miles a day, through the outer edges of the sun's influence. The termination shock, where the solar wind slows dramatically, and then the heliosheath, a churning, turbulent boundary zone. Scientists debated for years exactly when Voyager 1 would finally leave the sun's bubble entirely. The answer came in 2012. Data confirmed that Voyager 1 had crossed the heliopause, the boundary where the solar wind gives way to the plasma of interstellar space, making it the first human-made object in history to leave the sun's domain and enter the space between the stars. It is worth sitting with that for a second. Every human being who has ever lived, every war, every civilization, every love story, all of it happened inside the bubble Voyager 1 left behind in 2012. For 11 years after that, Voyager 1 kept him talking to Earth in a language engineers understood, structured packets of science and engineering data, arriving faint but clear across the growing gulf. Then, on November 14th, 2023, something changed. Voyager 1's onboard computer, a system called the Flight Data Subsystem, or FDS, whose job is to package up all the spacecraft's data before it's transmitted home, started sending back something that made no sense at all. Not silence, not an arrow, our code. Just an endless, repeating stream of ones and zeros with no discernible pattern. NASA engineers described it almost gently as the spacecraft's voice being replaced with a monotonous dial tone. The strange part was that Voyager 1 was still technically fine. It was still receiving commands from Earth. Its transmitter was still working. Somewhere out past the edge of the solar system, a machine built during the Ford administration was still faithfully listening for instructions from home. It just couldn't tell anyone what it was seeing or how it felt anymore. For 5 straight months, that's all NASA got back. Gibberish. Understand what that actually meant for the team at the Jet Propulsion Laboratory. Every command they sent took about 22 and a half hours to arrive. Every reply took another 22 and a half hours to come back. A single back-and-forth exchange, send a question, get an answer, burned the better part of 2 days. And they were troubleshooting a computer chip built in the 1970s. using documentation that, in some cases, existed only as old paper memos in an archive, because the engineers who originally designed the hardware had mostly retired or passed away. Voyager project scientist Linda Spilker later described the effort as something like an archaeological dig, flipping through decades-old records, trying to remember how a machine that predates the World Wide Web was ever wired together in the first place. In March of 2024, the team finally found it. A single memory chip inside the flight data subsystem had failed, most likely from sheer old age, nearly 50 years of cosmic ray. Bombardment and thermal cycling will do that to hardware never designed to last this long. That one chip held about 3% of the FDS's memory, including a chunk of code the system needed just to function. There was no fixing the chip itself. Nobody was flying out to interstellar space with a soldering iron. The only option was to essentially perform surgery on the spacecraft's memory using nothing but radio commands sent across 15 billion miles. Here's the problem they ran into. The corrupted code needed to be relocated somewhere else in memory. But Voyager's entire onboard computer has only about 70 kilobytes of storage, spread across System S that were never designed with room to spare. There wasn't a single empty space large enough to hold everything the broken chip had been storing. So the engineers broke the code apart. They split it into smaller pieces, rewrote each piece E so it would still function correctly when scattered instead of stored together, and then went hunting through Voyager's memory for unused corners, leftover space from processes the spacecraft no longer needed, like data transmission modes designed for when it was still close enough to Earth to send information at high speed. On April 18th, 2024, they sent the first patch. Then they waited. Not minutes, nearly 2 full days, accounting for the trip out and the reply back. On April 20th, the signal arrived. It worked. For the first time in 5 months, Voyager 1 sent home a clean, readable stream of engineering data. In a JPL conference room, a team that had spent months digging through 40-year-old memos to save a machine older than most of them watched their screens fill with numbers that finally made sense, and they celebrated like it was a championship game. Over the following weeks, they repeated the process, patching in the rest of the lost code piece by piece, until Voyager 1's science instruments came back online too. The spacecraft that had gone silent in a way nobody could explain had, quite literally, been talked back to life. By people who had never touched it using a machine, most of them were born long after it launched. So what is Voyager 1 actually finding? Out past the edge of everything we know? The honest answer is strange enough without embellishment. Interstellar space is not empty. Voyager 1's plasma wave instrument has picked up something scientists nicknamed the interstellar hum, a faint, persistent oscillation in the thin plasma between stars, quite different from the sharper, more sudden bursts of activity closer to the sun. It isn't a voice. It isn't a signal aimed at us. It's closer to the ambient background noise of the galaxy itself. The equivalent of standing in an empty room and realizing the air conditioning was on the whole time. Voyager 1 has also measured plasma density that's higher and magnetic fields that behave differently than models predicted before it got there. Some of what it found genuinely surprised scientists. For instance, the magnetic field direction barely changed as the spacecraft crossed from the solar wind into interstellar space, which wasn't fully expected. These aren't Hollywood mysteries. Artists, they're real, ongoing scientific puzzles that planetary physicists are still working through using Voyager's decades-old instruments, because there is still no other spacecraft out there to check the numbers against. And Voyager 1 has never stopped moving. It travels at roughly 38,000 miles an hour, carried by nothing but the momentum from its final planetary flyby in 1980. No engine. Burns. No course corrections. No active propulsion since. Its trajectory has been locked in for over 40 years. It isn't drifting toward anything mysterious. It's coasting in a straight, predictable line, roughly toward the constellation Ophiuchus. In about 40,000 years, by NASA's own projections, it will pass within a light year and a half of a dim red dwarf star called Gliese 445. It is not aimed at any star system, any planet, any destination at all. It is simply going the way a stone keeps skipping after the last time your hand touched it. Here's where the real story catches up to the dramatic one. Right now, as this fixed 49-year-old machine keeps falling outward, it's approaching a threshold no spacecraft has ever crossed. In mid to late November of 2026, Voyager 1 will become the first human-made object to reach a full light day from Earth, a distance of roughly 16 billion miles, or about 26 billion kilometers. A light day means exactly what it sounds like. At that distance, a radio signal traveling at the literal speed of light, the fastest anything can move in this universe, takes a full 24 hours just to arrive. Send a command on a Monday morning, and Voyager. If it responds immediately, that reply won't reach Earth until Wednesday. Think about what that actually costs the humans on the other end. Every single question, NASA asks Voyager 1 now takes the better part of 2 days to get an answer to. Every course correction command, every diagnostic check, every small conversation between a machine and the species that built it happens at the pace of a message in a bottle, except the bottle is moving at 670 million miles an hour, and the ocean is the width of the solar system. And the clock is working against them in another way, too. Voyager 1 is powered by a radioisotope thermoelectric generator, essentially a chunk of decaying plutonium converting heat into electricity. That power source loses strength every year, a slow bleed of roughly 4 watts annually, and it cannot be recharged or replaced. To keep the spacecraft alive, NASA has had to shut down heaters, then instruments one by one in a carefully chosen order, sacrificing pieces of the mission to keep the rest of it breathing. By early 2026, only 2 of Voyager 1's original science instruments were still switched on. So the coming light day milestone isn't a horror movie beat, it's something quieter and, honestly, more moving. A machine built by people who are mostly retired or gone now, powered by a fuel source that is running out, still faithfully calling home from farther away than anything humanity has ever sent, for just a little while longer. There is no alien signal. There was no secret DNA code hidden in Voyager 1's transmissions. Nobody redirected it toward an invisible door in space. What actually happened is, in its own way, harder to believe. A spacecraft with less computing power than a musical greeting card broke down 15 billion miles from the nearest repair shop, and a small team of engineers, armed with old paper memos and a signal, delay longer than a transatlantic flight, brought it back from the dead using nothing but radio waves. That happened. That's not speculation. That's the true story of November 2023 to April 2024, and NASA published every step of it. And in a matter of weeks from wherever you're watching this, Voyager 1 crosses a threshold that has never existed before in the history of our species, the point where light itself, the fastest thing there is, needs a full day to bridge the gap between us and something we built. We didn't need to invent a mystery. We're already living inside one. Voyager 1 was never supposed to still be talking to us. Its primary mission ended at Saturn in 1980. Everything since then, the pale blue dot, the crossing into interstellar space, the 5 months of gibberish, the impossible fix, the coming light day milestone, has been bonus time. A machine outliving every prediction anyone ever made about it, carried by momentum from a slingshot maneuver performed before most of the people reading this were born. At some point, nobody knows exactly when, but engineers expect it within the next several years, the power will finally run too. Lo, the last instrument will go dark, and Voyager 1 will stop talking. It won't stop moving. It will just go silent and keep going, carrying a golden record of whale songs and human greetings forever. Toward a star, it will take 40,000 years to pass. So subscribe if you want to be here when that light day milestone actually happens in November. Comment below and tell me, does the real story hit harder than the fiction? And share this with someone who still thinks the true story of Voyager 1 is boring, because it isn't. It's one of the strangest, most human things we've ever done.